Welcome to Math 60. In this video, we're going to talk about just how to set up word problems. We're not going to actually solve them so we can be more efficient with our time. Most of the students who struggle with word problems, they just have a hard time setting them up. So let's start with number 11. A bookstore sells a book for $117, which is 30% more than the wholesale price. What was the wholesale price? Define the variable, including units. So the very first step when it comes to solving a word problem is to set it up. We always want to start with the variable. So you could make that variable whatever you want, as long as you define it. So you're going to say W is the wholesale price. And then what happens is you start with the wholesale price, right? You add on the markup. It says it's a 30% more. So we take the wholesale price and what do we do to it? We're going to take 30% of it. So this is actually the markup. And it might be helpful to actually write it out a little bit in words. Oops. Markup. So if you write out that you're going to take the wholesale price and add the markup to get the sale price, that might be a good strategy for, getting the words on paper as to how to set it up. Sorry about the Zoom, you guys. Okay, so the equation then would be what? W is the wholesale price plus 30% of the wholesale price equals the sale price. What was the sale price? 117. So that's going to be the equation you solve. Now, if you were this is the equation that we want right here. And in section 2.8 of your book, we talk about modeling. So this is the model. If you were going to simplify, what would be the next step to simplifying? Yeah, and what would you get if you added those two together? 1.3W equals 117, okay? And then if you want to solve, you're going to divide both sides by 1.3. Where do you get the 1 from? Yeah, that's 1W. So putting that coefficient in front of the W could be good. That means that the sale price is 130% of the original price, of the wholesale price, I should say. The sale price is 130% of the wholesale price. Okay, so that was number 11. Let's go to the next one, number 12. A bill from a restaurant for a party of 8, which includes an 18% tip, is $220.90. $220.90. What was the bill before the tip was included? Again, we want to define the variable. So that's going to be always step 1, defining the variable. What variable do you want to use? Maybe B. This was the bill before the tip. What would the tip be then? If you had the bill, how do you calculate the tip? You're going to have 18% of the bill is the tip. Because you don't just add 18 cents. You have to add 18% of the bill, right? And then we have the whole total. So we have the bill plus 18% of the bill equals $220.90. If you add these two things together, what do you get? 118% of the bill. So the bill was 100%. We're going to pay 18% more to get the 220.90, and then if you wanted to solve, you would be dividing both sides by 118, or 1.18, sorry. And I'm not going to go ahead and do that. I'm just setting them up. Okay, any questions so far? Let's look at number 13. A clothes washer is priced at $246.74 during a 25% sale. What was the price of the washer before the sale? So again, defining the variable. P could stand for price before sale. How would you calculate the discount? What's the discount? 0.25 of P is going to be the discount. So we take the price and what do? Do we add the discount or do we subtract the discount? Oops, so we have to subtract the discount and we're going to get the sale price 246.74. That's what I'm saying. Once we subtract it. Now if you were to simplify that, what would you get if you simplified it? 0.75p equals 246.74. How do you solve for p? Divide both sides. Because essentially when you got that sale price, you only paid 75, when you get a 25% discount, you only pay 75% of the original price, right? Okay, let's look at number 14. A television service provider offers service of $102 per month as part of a 15% promotion. What would be the monthly rate without the promotion? So are you saving money or are you spending more with this promotion? So it's a discount. Again, it's the same kind of discount. We want to know the price before. So let's do M is the rate before promotion. Okay, the 15% discount is 15% of that is going to be the discount, right? Who can tell me what would be the equation that I would write for this? Because this is the original price. Here's the discount. We're going to take off the discount and we get 102. Yeah? Okay. So now what you actually paid, if you were to simplify, you have 0.85 M equals the 102. Okay, let's look at number 15. A hammer and a box of nails cost $30. The hammer costs 12 more than 2 boxes of nails. What is the price of each item? So let's start with one of the items. What item would you choose and what variable are you going to use? I actually might start with the nails. It's a good point because the hammer costs more, right? So N could be the price of nails. And then we only want to use one variable. So what could you write? What expression could you write for the price of the hammer? 12 plus 2n. How'd you get that? Yeah, so the hammer costs 12 more, so that's 12 plus, 12 more than 2 boxes of nails, so that's where we get the 2n. Now, how much did you spend altogether? You spent $30, so you bought 1 box of nails, and then you bought 1 hammer, 12 plus 2n, and you spent $30 altogether. Here's the nails, and right here is the hammer. That's 2 M's. Equals your total, right? So maybe writing it out in words, drawing a picture could also be helpful here. If you were going to simplify this, what would you get if you simplified? Yes, 12 plus 3n. How'd you get 3n? Yes, and then you're going to solve for n, right? You have like terms. You have 2n plus 1 more n gives you the 3n. So go ahead and you'll keep solving that. Number 16, an 8-foot board is cut into 2 pieces. So I'm going to start with the board is 8 feet. Draw my picture, okay? It's cut into 2 pieces. So here's my cut. One piece is 36 inches longer than the other one. So you have a short piece and you have a long piece, right? The short piece, we could start with, I don't know, S. S is equal to the short piece. in inches. And then what's the relationship? So what do I do to the short piece to give me the long piece? Short plus 36 inches is equal to the long piece, the longer piece, right? Now, do you see a problem with me setting up this equation? What's the problem so far? I have what? Well, this is my variable. The S is the short piece. Notice that I'm using inches. In inches. What's wrong with this board? This board is feet. How many inches is it? 96 inches because you multiplied it by 12, right? So now tell me what would the equation look like? S plus, that's the short piece, plus the long piece. The long piece is this whole thing. S plus 36, that's the long piece, is equal to 96. If you didn't change either this into, you could have changed 36 into feet. Yeah. Or, so you could also have S plus 3, if I wanted to make this into feet, equals 8. Either equation will work. One of them is going to give you inches. The other one is going to give you feet. Okay. So it's just a matter of making sure that's why we're saying here, include units in your defining of the variable, the long piece in inches. Then if they give the answer in feet, then yes, you would have to convert it back to feet. Question? What's the difference between these two? Is that what you're going to ask? 3. Okay, because 36 plus 3 feet S plus 36 inches or S plus 3 feet. Okay, let's look at number 17 now. An electrician charges a flat fee of $75 and then $55 for each hour of service. Write and solve a linear inequality showing how many hours of service will keep the total bill under $450. Define the variable you use, including units. So the electrician shows up at your house. Well, the first thing is defining the variable, actually. Sorry, what variable do we want to use? Because what are we trying to find out? How many hours? How many hours of service? That's the question we're trying to answer. So we could use H equals number of hours, right? $75 plus $55 for every hour. There's his rate. This is the flat fee, the initial fee, plus the hourly rate. Now, you want this bill to be under $450. So this is your bill right now. How will I make it under $450? Less than $450, right? We're going to use an inequality. Does it make sense why I'm using less than? Yes? Less than or equal to? That is a good question, and I think it could be up for debate. If I want it to be under $450, then I don't want it to actually equal $450. So in that case, I would probably use less than. If I want it to be, under $450 or equal to $450, I could use less than or equal to. Yeah. So I don't actually want to spend the whole thing. That's why I would just use the less than. That's a good question. Okay, number 18. A certain coffee shop usually takes in $1,500 in revenue by noon, and then only $1.79 for every minute it stays open. Write and solve a linear inequality showing how long the coffee shop should remain open in order to take in at least $2,000. So is at least $2,000 less than $2,000 or more? If I want at least, what's that? Yeah, it could be more than if I want. I want at least, I want that to be my minimum. Or greater than or equal to. But let's start with the variable. So what's my variable? What am I trying to find here? Well, how long. We're measuring the length of time in minutes. So let's use M is the number of minutes the coffee shop is open. And realize that the question is what you want your variable to be. The question is going to be answered by that variable. That's the thing we don't know. So anytime you're confused about, well, what's my variable? What's the thing I don't know? Just look for the question is my tip there. Okay, so they take in $1,500 in revenue by noon, and then only $1.79 for every minute. You see where I'm getting that equation right there? It's kind of worded a little strange, huh? Okay, we want this. This is the money that they make. We want this to be greater than or equal to $2,000 because we want them to make at least $2,000. So then we could go ahead after that and solve for M, right? Questions? You guys can ask me questions if you have them. Is this making sense? Okay, let's do number 19. A 12-ounce soda has 39 grams of sugar. How many grams of sugar are in a huge 32-ounce cup of soda? So you might draw your little cups. Here's the 12-ounce. The 12-ounce has 39 grams of sugar. Here's the 32-ounce. How much sugar is it? So S could be the grams of sugar. And actually, we can use a proportion here. So 12 is to 39 as 32 is to S. That's just one way to set up that proportion. There could be multiple ways of setting it up correctly, and there could also be multiple ways of setting it up incorrectly. But essentially, if you're consistent, you're like, okay, well, here's my ounces, so ounces to ounces, and then grams to grams, right? And they're in the same location. You might have said 12 ounces, 32 ounces equals 39 grams equals S grams. That would actually give you the same thing when you cross multiply, right? Because that's how you would solve this. You could cross multiply. You see that I would be cross multiplying the exact same numbers. So here I did all my ounces and I stayed consistent. These are my grams now. You know, ounces go this way, grams go this way, but they correlate, you know, to the one that they belong to. Is that all of them? Okay. Actually, there's one more. There's one more. And don't worry, you can always go back because I'm recording, okay? So number 20 says, it takes 22 minutes to mow your backyard, which is 610 square feet of easy access grass. Your neighbors are out of town and have asked you to mow their lawn, which is a similar accessible space. If the lawn is 760 square feet, how long will it take you to mow it? Set up a proportion and solve to find the variable. So maybe you draw the lawn. Here's your lawn. It's 610 square feet. Takes you 22 minutes. Their lawn is 760 square feet. We don't know how many minutes. So we might say M is the number of minutes. And there's my lawns, but guess what? There's my proportion as well. Because if I keep the feet with the feet and the minutes with the minutes, I could have also done 22 minutes for 610 equals I don't know how many minutes for the 760. I could also put my minutes together, 22 and M, 610. This is my yard, and 760. There's a number of different ways I could set up that proportion and get the same answer. It doesn't really matter. So long as you're consistent, you want to keep the minutes. Here I'm keeping the minutes together, and I'm keeping the lawns together, right? And these going from small to large. Here I'm keeping all the minutes, and here I'm keeping the lawn size. But the 22 relates to the 610. The unknown minutes relates to the 760. Are there any other word problems that you can think of that you want to go over that even aren't on here? Maybe we need to add in, let's add in one on a lot of people have struggled with the perimeter. So I'm just going to make up a perimeter problem. So just get out some regular paper and you can write this down. Every time you have a perimeter problem, I would start with a picture. Okay? They told me that the perimeter is 252 feet. They told me that the width is 5 feet longer than the length. The length is 5 feet longer than 3 times the width. And I just changed that from length and width. And I'm just making this up, you guys. This is not written anywhere, but this is very similar to the problems you've seen on web work. I'm saying usually the width is smaller. So if we start with W is the width, who can tell me the expression for the length? What would be the expression for the length based on this information? Well, it's 3 times the width and it's 5 longer. So you could also label every single side. If you want to write an equation for the perimeter, what do we do to find the perimeter? We add up all the sides. Good. So we would have, or you could use the formula, 2W plus 2 lengths. Well, the length is 3W plus 5 equals the total perimeter 252. Can you think of any other word problems that you've been struggling with that you want me to show an example of before I push stop? Way to be on the spot, right? Okay, well, that's going to wrap up our discussion today on word problems.